Causal determinism is the philosophical notion that every event or state of affairs, including human actions and decisions, is the consequence of preceding events in accordance with natural laws. This idea suggests that given the state of the universe at a particular time, the state of the universe at any subsequent time is entirely determined by these laws. The history and development of causal determinism spans centuries, encompassing contributions from various philosophical and scientific traditions. It has evolved through various philosophical and scientific paradigms, from ancient Greek philosophy to modern quantum mechanics. It has shaped our understanding of the universe and human behavior. While it offers a framework for predictability and order, it also challenges deeply held notions of free will and moral responsibility, making it a rich and ongoing area of inquiry and debate. Howdy, I'm just some random nude dude sitting in my closet talking to myself. It's also where I celebrate the power of free thinking and encourage bold ideas. As a society, we're often afraid to challenge the norms and think outside the box. But here, I embrace the unconventional. So sit back, relax, and join me on this journey of exploration, where we embrace our inner nude dude and push boundaries to discover new perspectives. Causal determinism stands as one of the most enduring and contentious concepts in human thought, shaping our understanding of the universe, human behavior, and the very foundations of morality. At its core, causal determinism proposes that every event is necessitated by preceding events and natural laws, implying a universe governed by fixed principles where every action is the inevitable outcome of prior causes. This deterministic worldview has been a cornerstone of scientific inquiry, providing the framework for predicting and explaining the behavior of physical systems and natural phenomena. From the ancient philosophical debates of pre-Socratic thinkers to the cutting-edge research of contemporary scientists, the concept of causal determinism has been a focal point of inquiry across diverse disciplines. Throughout history, philosophers, scientists, and scholars have grappled with fundamental questions about the nature of causality, free will, and moral responsibility, seeking to unravel the complexities of deterministic frameworks and their implications for human understanding. This exploration of causal determinism aims to navigate the intricate tapestry of ideas, theories, and perspectives that have shaped our understanding of cause and effect throughout the ages. Spanning ancient philosophical treatises to modern scientific discoveries, this journey will delve into the historical roots, conceptual intricacies, and contemporary debates surrounding causal determinism. The historical foundations of causal determinism trace back to ancient civilizations, where early thinkers pondered the nature of the universe and the relationship between cause and effect. From deterministic worldview of ancient Greek philosophers to the theological determinism of medieval theologians, the concept of a universe governed by fixed laws has been a recurring theme throughout human thought. In ancient Greece, philosophers such as Parmenides and Democritus grappled with questions about the ultimate nature of reality and the role of determinism in shaping the cosmos. Parmenides posited a timeless and unchanging universe governed by necessity, while Democritus proposed a mechanistic worldview based on the interactions of indivisible atoms. Medieval theologians wrestled with the implications of divine determinism, reconciling the belief in an omnipotent God with human freedom and moral responsibility. Figures like Augustine and Aquinas sought to harmonize divine foreknowledge with human agency, offering theological frameworks that navigated the tension between determinism and free will. The early modern period witnessed profound developments in the philosophy of determinism, as thinkers such as Descartes, Spinoza, and Leibniz grappled with questions about the nature of causality and human freedom. Descartes proposed a dualistic framework that separated the deterministic physical world from the realm of the mind, while Spinoza and Leibniz articulated monistic views that integrated determinism with notions of divine providence and pre-established harmony. The scientific revolution of the 17th and 18th centuries ushered in a new era of scientific inquiry, where pioneers like Galileo, Newton, and Laplace laid the foundations for modern deterministic thought. Newton's laws of motion and universal gravitation provided a comprehensive framework for understanding the deterministic nature of physical systems, while Laplace's vision of a deterministic universe governed by causal laws captured the imagination of scientists and philosophers alike. The 19th century saw significant advancements in science and philosophy, with developments in thermodynamics, electromagnetism, and evolutionary biology challenging and refining deterministic frameworks. From the formulation of the laws of thermodynamics to Darwin's theory of evolution by natural selection, new insights into the nature of causality and complexity reshaped our understanding of determinism and its implications for the natural world. The 20th century brought profound challenges to the deterministic worldview, as discoveries in quantum mechanics, chaos theory, and the philosophy of science raised questions about the nature of causality, predictability, and human agency. From Heisenberg's uncertainty principle to the emergence of chaos theory, new perspectives emerged that challenged classical determinism and invited reevaluation of our understanding of cause and effect. In contemporary thought, the debate over causal determinism continues to evolve, with scholars exploring diverse perspectives on the nature of causality, free will, and moral responsibility. Compatibilist, incompatibilist, and emergentist viewpoints offer unique insights into the complexities of deterministic frameworks and their implications for human understanding and ethical reflection. The origins of determinism can be traced back to ancient Greek philosophy, where early thinkers began to explore the nature of the universe and the principles that govern it. These foundational ideas laid the groundwork for later, more formalized concepts of causal determinism. Heraclitus is often associated with the idea that everything is in a state of constant change, famously stating that one cannot step into the same river twice. Despite this focus on change, Heraclitus also believed in a fundamental order or reason, logos, governing the cosmos. This logos was the rational principle underlying all changes, suggesting a deterministic structure to the universe where all events are interconnected through this rational order. Democritus is considered one of the founders of atomism. He proposed that everything in the universe is composed of small, indivisible particles called atoms, which move through the void and combine in various ways to form the observable world. According to Democritus, all phenomena, including human thoughts and actions, can be explained by the interactions and arrangements of these atoms. This view implied a deterministic universe where every event is the result of prior atomic interventions, following natural laws without any need for divine intervention or randomness. The Stoic school of philosophy, founded in the early 3rd century BCE, further developed deterministic ideas. Prominent Stoic philosophers like Zeno of Citium, Cleanthes, and Chrysippus articulated a comprehensive deterministic worldview. Chrysippus, a key figure in Stoicism, argued that the universe is a coherent deterministic system governed by divine reason, logos, or fate. He believed that everything happens according to a predetermined plan laid out by the logos, which is both rational and providential. This deterministic order was not seen as opposed to human freedom. Rather, the Stoics introduced the concept of compatibilism, where freedom is understood as the ability to act in accordance with one's nature and rational understanding. Stoics maintain that while external events are determined by fate, individuals have control over their internal states, how they perceive and respond to these events. By cultivating wisdom and virtue, individuals can align themselves with the rational order of the universe, achieving a form of inner freedom despite external determinism. This perspective laid an early foundation for later compatibilist views that seek to reconcile determinism with moral responsibility. While not strictly deterministic, Epicureanism, founded by Epicurus, also contributed to the discourse on causation and determinism. Epicurus adopted the atomic theory of Democritus, but introduced the concept of swerve, or klinemen, to account for free will. According to Epicurus, atoms occasionally deviated from their expected paths spontaneously. This indeterministic element was meant to preserve the possibility of free will and moral responsibility, countering the strict determinism of atomism. Epicurus's introduction of indeterminacy challenged the deterministic views of his time and provided an early argument against the ideas that all events are strictly determined by prior causes. His ideas influenced later discussions on the balance between determinism and indeterminism. The ancient roots of determinism, particularly through the works of Heraclitus, Democritus, and the Stoics, laid the groundwork for understanding the universe as a place governed by rational and natural laws. These early thinkers explored the tensions between order and change, causation and freedom, establishing foundational ideas that would be expanded on by later philosophers and scientists. While the Stoics developed an early form of compatibilism, Epicurus introduced elements of indeterminism to preserve human freedom, demonstrating the diversity of thought on these issues even in ancient times. During the medieval period, the tension between divine foreknowledge, divine providence, and human free will became central themes in the philosophical and theological discourse. Key figures such as Augustine of Hippo and Thomas Aquinas made significant contributions to the understanding of determinism and free will, shaping the medieval intellectual landscape. Augustine, one of the most influential Christian theologians, extensively addressed the issue of free will and divine foreknowledge in his writings. Augustine grappled with the apparent conflict between God's omniscience and human free will, aiming to reconcile the two within a Christian framework. Augustine posited that God's knowledge of future events does not cause those events to happen. Instead, God exists outside of time and perceives all of time, past, present, and future, simultaneously. Kind of like Q. Thus, God's foreknowledge is like an observer's knowledge rather than a causal determinant of future events. The perspective implies that although God knows what will happen, human beings still make free choices. Augustine also explored the concept of free will in the context of original sin. He argued that human beings have free will, but this freedom is constrained by the inherent sinfulness from Adam and Eve. According to Augustine, while humans can make free choices, their will is often inclined towards sin due to their fallen nature. This duality acknowledges human responsibility while recognizing limitations imposed by original sin. Augustine's views on predestination further complicated the discussion of determinism and free will. He believed that God predestines certain individuals for salvation, a doctrine that seems to imply a deterministic outlook. However, he maintained that this predestination is based on God's foreknowledge of individuals' future free actions, thereby attempting to preserve the notion of free will within a deterministic framework of divine providence. Thomas Aquinas, a pivotal figure in medieval philosophy and theology, sought to harmonize Christian doctrine with Aristotelian philosophy. His work on determinism and free will is particularly notable in his synthesis on faith and reason. Aquinas, like Augustine, argued that God's foreknowledge does not negate human free will. He proposed that God, existing outside of time, knows all events eternally and infallibly. Thus, this knowledge does not impose necessity on human action. God's knowledge is analogized to that of an external witness who sees the entire temporal sequence all at once. God read the last chapter of the book. Aquinas distinguished between different types of causation. He recognized that while God is the first cause and sustainer of all existence, secondary causes, including human free will, operate within the created order. Human actions are contingent events that result from free will, even though they are ultimately grounded in God's sustaining power. Aquinas' concept of natural law also plays a role in his understanding of determinism and free will. He believed that humans, through their rational nature, can discern the natural law and act according to it. This capacity for rational choice underpins moral responsibility, as individuals freely choose to align their actions with natural law or deviate from it. Medieval thought on determinism and free will was not confined to Christian philosophers. Islamic and Jewish scholars also engaged with these issues, often in dialogues with the Greek philosophical tradition. Al-Ghazali, an influential Islamic theologian and philosopher, argued for the compatibility of divine omnipotence with human free will. He contended that God's will encompasses all events, but humans still possess the capacity to choose freely within the framework of divine decree. Maimonides, a preeminent Jewish philosopher, integrated Aristotelian philosophy with Jewish theology. He upheld that God's foreknowledge does not comprise human free will, proposing that God's knowledge is fundamentally different from human knowledge, and thus does not impose determinism on human actions. Medieval thought on determinism and free will was marked by a complex interplay of theological and philosophical ideas. Augustine and Aquinas made significant strides in reconciling divine foreknowledge with human freedom, establishing frameworks that allowed for moral responsibility within a deterministic universe shaped by divine providence. Their work influenced subsequent Christian, Islamic, and Jewish thinkers who continued to explore these themes within their respective religious and philosophical traditions. This period laid important groundwork for later discussions on determinism and free will, bridging ancient philosophical insights with medieval theological concerns. The early modern period, spanning roughly from the 17th to the 18th centuries, saw profound developments in the philosophy of determinism. This era was characterized by the rise of scientific inquiry and rationalism, which influenced how philosophers conceived of the universe and human freedom. Key figures in this period include René Descartes, Baruch Spinoza, and Gottfried Wilhelm Leibniz, who each offered unique contributions to the understanding of determinism. René Descartes, often regarded as the father of modern philosophy, introduced a dualistic framework that separated the mind from the physical world. Descartes' famous assertion, cogito ergo sum, I think, therefore I am, emphasized the fundamental distinction between the thinking substance, res cogitans, and the external substance, res extensa. For Descartes, the physical world operates according to deterministic laws of nature akin to a machine. This mechanical view of the universe laid the groundwork for classical determinism in the natural sciences. Despite his mechanistic view of the physical world, Descartes maintained that the mind possesses free will. He argued that the mind, being a non-physical substance, is not bound by the deterministic laws governing the physical realm. This interaction between mind and body, though mysterious, allowed for human beings to exercise free will within a deterministic framework. Descartes' emphasis on mathematical principles and mechanistic explanations influenced the development of scientific determinism. His work laid the foundation for the scientific revolution, which sought to explain natural phenomena through universal laws. Baruch Spinoza proposed a radical form of determinism that integrated metaphysics with a strict causal framework. Spinoza's philosophy is grounded in the idea of monism, where there is only one substance, which he identified as God or nature. According to Spinoza, everything that exists is a mode or attribute of this single substance. The ontological framework implies that all events and entities are interconnected and follow necessarily from the nature of one substance. Spinoza's determinism is often described as necessitarianism, which holds that everything happens out of necessity. He argued that everything follows from the nature of God or nature, with the same necessity as the properties of a triangle follow from its definition. For Spinoza, free will is an illusion. Human beings believe that they are free because they are conscious of their desires, but ignorant of the causes that determine those desires. Despite his strict determinism, Spinoza redefined freedom as understanding necessity. He proposed that true freedom consists in rational understanding of the deterministic order of nature and aligning oneself with it. By achieving this intellectual understanding, individuals can attain peace of mind and ethical living, even in a deterministic universe. You just have to accept the predetermination. Almost like we're a simulation. Gottfried Wilhelm Leibniz developed a unique deterministic framework through his concept of pre-established harmony and mondology. Leibniz introduced the idea of monads, which are simple, indivisible, and immaterial substances that constitute reality. Each monad is unique and contains within it a pre-programmed set of instructions that determine its development and interactions. Despite the apparent interaction between monads, Leibniz argued that there is no direct causal influence between them. Instead, God orchestrates a pre-established harmony where each monad operates in perfect synchronization with others. Leibniz believed that God's creation of the best possible world included a predetermined harmony among all monads. This view upholds a deterministic universe where every event is foreseen and planned by God, yet it allows for a form of freedom within this predetermined structure. Human actions are predetermined by their monad's internal principles, but because these actions align with God's perfect plan, individuals retain a semblance of free will. It's an illusion. Leibniz's principles of sufficient reason states that nothing happens without a reason. This principle underpins his deterministic worldview, suggesting that every event and existence has a rational explanation grounded in the nature of monads and the pre-established harmony. Empiricists like David Hume offered critical perspectives on causation and determinism. Hume challenged the notion of causation by arguing that our belief in causality is based on habit and experience rather than logical necessity. According to Hume, we observe events constantly conjoined but do not directly perceive necessary connections between them. This skepticism undermined the certainty of deterministic claims by highlighting the limits of human knowledge about causal relationships. Hume's empiricism emphasized that our understanding of the world is grounded in sensory experience and the patterns we observe. He suggested that while we may infer causal relations from experience, these inferences do not provide absolute certainty. This perspective introduced a level of epistemological humility to discussions of determinism. The early modern period witnessed significant advancements in the philosophical understanding of determinism. Descartes' dualism, Spinoza's necessitarianism, and Leibniz's pre-established harmony each offered distinct deterministic frameworks that integrated metaphysical principles with scientific inquiry. While Descartes maintained a separation between the deterministic physical world and the free mind, Spinoza and Leibniz proposed more integrated deterministic systems where freedom is reinterpreted within a causal framework. Empiricists like Hume added a critical dimension to these discussions by questioning the certainty of causal relationships and emphasizing the limits of human knowledge. Together, these thinkers laid the foundations for modern debates on determinism, free will, and the nature of causation, influencing subsequent developments in philosophy and science. The scientific revolution, spanning from the 16th to the 18th centuries, marked a profound transformation in the understanding of the natural world. This period saw the development of key scientific principles and methodologies that solidified the concept of a deterministic universe. Pioneering scientists such as Isaac Newton, Galileo Galilei, and Pierre-Simon Laplace played crucial roles in shaping the deterministic worldview that emerged from this area. Galileo was a pivotal figure in the early stages of the scientific revolution. His work laid the foundation for mathematical formulation of physical laws. Galileo emphasized the importance of mathematics in describing natural phenomena. He argued that the universe is written in the language of mathematics, and understanding this language is key to uncovering the laws of nature. This approach marked a significant shift from qualitative descriptions to quantitative analysis, paving the way for a deterministic understanding of physical processes. Galileo's formulation of the laws of inertia stated that an object in motion will remain in motion unless acted upon by an external force. This principle challenged Aristotelian notion that objects require a continuous force to maintain motion. Galileo's work on inertia contributed to the development of classical mechanics, which described the motion of objects through deterministic laws. Isaac Newton is perhaps the most iconic figure in the scientific revolution, whose contributions cemented the deterministic framework of classical physics. Newton's three laws of motion, outlined in his seminal work, Philosophiae Naturalis Principia Mathematica in 1687, provided a comprehensive mathematical description of the motion of objects. These laws demonstrated that the behavior of physical systems could be predicted with great precision if the initial conditions and forces acting upon them were known. Newton's laws of universal gravitation described the force of attraction between two masses. He showed that the same force governing the motion of planets also applied to objects on Earth. This unification of celestial and terrestrial mechanics under a single set of deterministic laws was revolutionary, illustrating the predictability and order of the natural world. Newton's deterministic universe was often likened to a clockwork mechanism, where every part moves in accordance with fixed laws. This metaphor underscores the belief that, given complete knowledge of the initial conditions and forces, the future states of any physical system could be precisely determined. Newton's work epitomized the mechanistic worldview that dominated scientific thought for centuries. Pierre-Simon Laplace extended Newtonian mechanics into a comprehensive deterministic philosophy. Laplace famously articulated the concept of causal determinism through his thought experiment known as Laplace's demon. He imagined an intellect that, if it knew the precise location and momentum of every atom in the universe at a given time, he could predict the future and retrodict the past with absolute certainty. This idea encapsulated the deterministic view that all events are the inevitable result of preceding conditions and laws. Laplace also contributed to the field of probability and statistical mechanics. While acknowledging the practical limitations in predicting complex systems, he maintained that these limitations were due to human ignorance rather than indeterminism in nature. Laplace's work in probability theory provided tools to deal with uncertainty in a deterministic framework, reinforcing the notion that apparent randomness could be understood through underlying deterministic principles. The deterministic models developed during the scientific revolution emphasized predictability and control. Scientists believed that by understanding the laws governing natural phenomena, they could predict future events and manipulate conditions to achieve desired outcomes. This confidence in scientific predictability influenced various fields, from astronomy and physics to engineering and technology. The success of Newtonian mechanics fostered a reductionist approach to science, where complex systems were understood by breaking them down into the simplest components and studying the deterministic interactions between these parts. This approach dominated scientific methodology and remained influential well into the 20th century. Despite the dominance of deterministic thinking, the scientific revolution also encountered challenges. Complex systems, such as weather patterns and biological processes, often prove difficult to predict accurately, primarily because we don't know everything or maybe anything. These practical limitations hinted at the complexities that would later be addressed by chaos theory and quantum mechanics. The scientific revolution solidified the concept of a deterministic universe governed by universal laws. Through the pioneering work of Galileo, Newton, and Laplace, the idea that natural phenomena could be precisely described and predicted using mathematical principles became a cornerstone of scientific thought. This deterministic worldview shaped the development of modern science, fostering a belief in predictability, control, and the power of human reason to unlock the mysteries of nature. However, the limitations encountered during this period also set the stage for future developments that would challenge and refine the deterministic paradigm. The 19th century witnessed significant advancements in various scientific disciplines, leading to a deeper understanding of determinism and its implications. Key developments in thermodynamics, electromagnetism, and evolutionary biology further refined the deterministic framework established during the scientific revolution. Prominent figures such as James Clerk Maxwell, Ludwig Boltzmann, and Charles Darwin made groundbreaking contributions that shaped the discourse on determinism. The development of thermodynamics and statistical mechanics introduced new dimensions into the understanding of determinism, particularly in dealing with complex systems and probabilistic phenomena. The formulation of the first and second laws of thermodynamics had profound implications for determinism. The conservation of energy principle, articulated as the first law of thermodynamics, reinforced the deterministic view that energy is neither created nor destroyed, but transformed from one form to another. This law implied a fixed amount of energy in the universe, subject to predictable transformations. The second law of thermodynamics, stating that the entropy, or chaos, of an isolated system tends to increase over time, introduced an element of irreversibility and disorder. While the second law suggested a directional flow of processes towards increased entropy, it did not negate determinism but rather framed it within the context of inevitable increase in disorder. Statistical mechanics, developed by Ludwig Boltzmann and others, sought to explain the macroscopic properties of systems based on the behavior of their microscopic components. Boltzmann's work introduced probabilistic methods to describe the behavior of particles in a gas. While individual particle motions were deterministic, their collective behavior could be described statistically. This approach highlighted that macroscopic phenomena could be predictable in a probabilistic sense, even if the exact state of each particle was unknown. Boltzmann's definition of entropy provided a link between microscopic states and macroscopic thermodynamic quantities. His famous equation, which I'm not going to try to read and will be in the description if you're really interested, quantified the relationship between the micro and macro levels, reinforcing a deterministic yet statistical view of thermodynamic processes. The unification of electricity and magnetism into a single theory of electromagnetism by James Clerk Maxwell represented another leap forward in deterministic physics. Maxwell's equations described how electric and magnetic fields interact and propagate through space. These four equations provided a deterministic framework for understanding electromagnetic phenomena, predicting the behavior of electric and magnetic fields with high precision. Maxwell's theory showed that light is an electromagnetic wave, unifying optics with electromagnetism. This unification reinforced the deterministic nature of physical laws across different domains of physics. The success of Maxwell's equations in explaining and predicting electromagnetic phenomena strengthened the belief in a deterministic universe governed by mathematical laws. Charles Darwin introduced a new perspective on determinism through his theory of evolution by natural selection. Darwin's theory posited that species evolve over time through the differential survival and reproduction of individuals with advantageous traits. While the process of natural selection is not strictly deterministic in the same way as physical laws, it introduced a form of causal determinism in biological systems. The mechanisms of genetic variation and natural selection operate according to causal principles. Mutations occur randomly, but their propagation through populations follows deterministic patterns shaped by environmental pressures and reproductive success. Although evolution involves random mutations, the overall process can be understood in a deterministic framework where certain traits become more common in a population due to their adaptive value. Darwin's work extended determinism to the realm of biology, suggesting that diversity of life and the development of complex organisms can be explained through natural laws and processes. This view challenged earlier notions of divine intervention and underscored the power of naturalistic explanations. The scientific advancements of the 19th century had significant philosophical implications, influencing contemporary and future debates on determinism and free will. The success of thermodynamics, electromagnetism, and evolutionary biology reinforced a materialistic and mechanistic worldview. This perspective emphasized that all natural phenomena, including life and consciousness, could be explained through physical processes and deterministic laws. The deterministic frameworks established by 19th century science posed challenges to traditional notions of free will. If human behavior and thought processes were subject to the same deterministic principles as physical and biological systems, the scope for genuine free will seemed limited. In response to these challenges, some philosophers and scientists developed compatibilist theories, arguing that free will could be understood in a way that is compatible with determinism. These theories suggested that human freedom involves acting in accordance with one's own motives and reasons, even if these are ultimately determined by prior causes. The 19th century was a period of remarkable scientific progress that further entrenched the deterministic view of the universe. Developments in thermodynamics and statistical mechanisms introduced probabilistic methods that complemented deterministic laws, while electromagnetism provided a unified framework for understanding a wide range of physical phenomena. Darwin's theory of evolution extended determinism to the biological realm, offering naturalistic explanations for the diversity of life. These scientific advancements had profound philosophical implications, challenging traditional views of free will and reinforcing the mechanistic and materialistic outlook that continues to influence contemporary thought. The 20th century brought significant challenges to the deterministic worldview that had dominated scientific and philosophical thought since the scientific revolution. Key developments in quantum mechanics, chaos theory, and the philosophy of science raised profound questions about the nature of causality, predictability, and the limits of scientific knowledge. This period saw a shift from classical determinism to a more nuanced understanding of the interplay between determinism and indeterminism. The advent of quantum mechanics in the early 20th century fundamentally transformed our understanding of physical reality. Key figures such as Niels Bohr, Werner Heisenberg, and Albert Einstein played pivotal roles in developing and interpreting quantum theory. Werner Heisenberg's uncertainty principle, formulated in 1927, states that it is impossible to simultaneously know both the exact position and momentum of a particle. This principle implies a fundamental limit to the precision in which certain pairs of physical properties can be known, introducing an element of indeterminacy at the quantum level. The uncertainty principle challenges classical determinism by suggesting that there are inherent limits to predictability in the behavior of particles. This indeterminacy is not due to measurement errors, but is a fundamental aspect of nature. The concept of wave-particle duality, central to quantum mechanics, posits that particles, such as electrons, exhibit both wave-like and particle-like properties. This duality challenges classical notions of particles as discrete, localized entities and introduces probabilistic descriptions into their behavior. Quantum mechanics describes the behavior of particles in terms of probabilistic distributions rather than deterministic trajectories. The outcome of certain measurements can only be predicted probabilistically, reflecting an inherent indeterminism in quantum phenomena. The phenomenon of quantum entanglement, where particles become correlated in such a way that the state of one particle instantaneously affects the state of another, even across large distances, challenges classical concepts of locality and causality. Entanglement suggests that the behavior of entangled particles is not determined solely by their local interactions, complicating the deterministic picture of causality in classical physics. Chaos theory, emerging in the latter half of the 20th century, revealed that deterministic systems can exhibit unpredictable behavior due to their sensitivity to initial conditions. Often referred to as the butterfly effect, this concept, popularized by meteorologist Edward Lorenz, illustrates how small differences in initial conditions can lead to vastly different outcomes in chaotic systems. While chaotic systems are governed by deterministic laws, their extreme sensitivity to initial conditions means that long-term prediction is practically impossible. This unpredictability challenges the classical notion that determinism implies predictability. Chaos theory deals with nonlinear systems, where outputs are not directly proportional to inputs. These systems can exhibit complex, unpredictable behavior that is not evident in linear systems. The study of nonlinear dynamics and chaos demonstrates that deterministic systems can generate complex, seemingly random behavior, highlighting the limitations of reductionist approaches in explaining natural phenomena. Philosophers of science such as Karl Popper and Thomas Kuhn contributed to the evolving understanding of scientific knowledge and its limits, further challenging deterministic views. Karl Popper argued that scientific theories should be falsifiable, meaning that they can be tested and potentially disproven by empirical evidence. This view emphasized the provisional nature of scientific knowledge and the ongoing process of hypothesis testing and revision. Popper's emphasis on falsifiability highlights the limitations of claiming absolute determinism in scientific theories, as all scientific knowledge is subject to revision based on new evidence. Thomas Kuhn's concept of paradigm shifts, introduced in his work The Structure of Scientific Revolutions, describes how scientific progress occurs through shifts in dominant theoretical frameworks rather than through a straightforward accumulation of knowledge. Kuhn's analysis suggests that scientific understanding is historically contingent and subject to radical changes, challenging the notion of a fixed deterministic framework for explaining natural phenomena. Albert Einstein's theories of special and general relativity also introduced new perspectives on determinism and the nature of space and time. Special relativity, formulated in 1905, revealed that the laws of physics are the same for all observers in uniform motion, and that the speed of light is constant regardless of the observer's frame of reference. While special relativity is consistent with deterministic principles, it challenges classical notions of absolute space and time, introducing the concept of space-time and the relativity of simultaneity. General relativity, developed in 1915, describes gravity as the curvature of space-time caused by mass and energy. This theory provided a new deterministic framework for understanding gravitational phenomena. General relativity remains a deterministic theory, but its implications for the nature of the universe, such as the possibility of black holes and the expansion of the universe, highlight the complexity and richness of deterministic models. The 20th century posed significant challenges to classical determinism through developments in quantum mechanics, chaos theory, and the philosophy of science. Quantum mechanics introduced fundamental indeterminacy at the microscopic level, while chaos theory revealed the limits of predictability in deterministic systems. Philosophers of science emphasized the provisional and contingent nature of scientific knowledge, questioning the absoluteness of deterministic claims. Despite these challenges, determinism remained a powerful concept, though it evolved to accommodate new insights into the complexity and probabilistic nature of the universe. The interplay between determinism and indeterminism continues to shape contemporary scientific and philosophical discourse, reflecting a more nuanced understanding of causality and predictability in the natural world. Modern discussions of causal determinism involve interdisciplinary contributions from philosophy, neuroscience, and psychology. Advances in neuroscience have shown that many human actions are influenced by neural processes, reigniting debates about the extent of free will. Philosophers continue to explore the implications of determinism, with compatibilists like Daniel Dennett arguing that determinism does not preclude moral responsibility, while incompatibilists like Dirk Pereboom reject the notion of free will altogether. In contemporary thought, the concept of causal determinism continues to be a subject of intense debate and scrutiny. Advances in science, philosophy, and interdisciplinary studies have led to a nuanced understanding of determinism and its implications for various aspects of human life and the natural world. Contemporary perspectives on determinism encompass a wide range of viewpoints, including compatibilist, incompatibilist, and emergentist stances, each offering unique insights into the nature of causality, free will, and moral responsibility. Compatibilist perspectives seek to reconcile determinism with the existence of free will and moral responsibility. Compatibilists argue that even if the universe operates according to deterministic laws, human beings can still be considered free and morally responsible for their actions. Compatibilists propose that freedom should be understood in terms of the absence of external constraints or coercion, rather than the ability to choose independently of causal influences. According to this view, as long as individuals act in accordance with their desires, beliefs, and values, they can be considered free agents, even within a deterministic framework. Compatibilists contend that moral responsibility is compatible with determinism because it does not require the ability to choose differently in a given situation. Instead, moral responsibility hinges on factors such as rational deliberation, intentionality, and the capacity to respond to social norms and expectations. Incompatibilist perspectives reject the compatibility of determinism with free will and moral responsibility. Incompatibilists argue that if every event is causally determined, then genuine freedom and moral agency are illusory. Some incompatibilists, known as metaphysical libertarians, posit that free will requires the existence of indeterminism in the universe. They argue that genuine freedom entails the ability to choose between genuinely alternative courses of action, free from deterministic constraints. Hard determinists take the opposite stance, asserting that determinism is incompatible with free will and moral responsibility. They argue that if every event is causally determined by prior conditions, then individuals cannot be held morally accountable for their actions, as they have no genuine control over them. Emergentist perspectives propose that while the universe operates according to deterministic laws at lower levels of organization, higher-level phenomena such as consciousness, intentionality, and social interactions may exhibit emergent properties that cannot be reduced to deterministic processes. Emergentists argue that complex systems, such as the human brain and social structures, exhibit emergent properties that arise from the interactions of simpler components. While these emergent properties may be influenced by deterministic processes at lower levels, they cannot be fully predicted or explained by them. Sounds like we're getting back to monads. Emergentism challenges reductionist accounts of determinism by emphasizing the irreducibility of higher-level phenomenon to deterministic explanations. While emergentist perspectives do not deny the existence of deterministic laws at lower levels, they suggest that these laws may not fully determine the behavior of complex systems. Contemporary discussions on determinism often involve interdisciplinary approaches that integrate insights from physics, neuroscience, psychology, and philosophy. Researchers seek to explore the implications of deterministic frameworks for understanding human cognition, behavior, and societal dynamics. Advances in neuroscience have shed light on the neural mechanisms underlying decision-making and agency. While neuroscientific research often emphasizes the role of deterministic processes in brain function, it also highlights the complexity and plasticity of neural networks, raising questions about the extent to which deterministic explanations can fully account for human behavior. Philosophical discussions on determinism extend to ethical and social domains, addressing questions about justice, autonomy, and the impact of deterministic worldviews on societal attitudes and policies. Scholars explore how determinism intersects with issues such as criminal responsibility, distributive justice, and the ethics of technology and artificial intelligence. Contemporary perspectives on causal determinism reflect a rich tapestry of philosophical, scientific, and interdisciplinary inquiry. While debates about the compatibility of determinism with free will and moral responsibility continue to animate philosophical discourse, contemporary scholarship also emphasizes the need for nuanced approaches that integrate insights from multiple disciplines. By embracing the complexity of deterministic frameworks and their implications for human understanding and ethical reflection, contemporary perspectives on determinism offer new avenues for exploring the nature of causality, agency, and responsibility in our increasingly interconnected world. Causal determinism, the view that every event is necessitated by preceding events and natural laws, carries profound implications for our understanding of the universe, human behavior, and moral responsibility. While deterministic frameworks have been influential in science and philosophy, they also raise challenging questions about free will, moral agency, and the nature of causality. One of the most significant implications of causal determinism is its apparent challenge to the existence of free will. If every action and decision is causally determined by prior events and natural laws, it seems to leave no room for genuine human choice or autonomy. This raises questions about the compatibility of determinism with moral responsibility. Some philosophers, known as compatibilists, argue that determinism is compatible with free will and moral responsibility. They contend that even if our actions are causally determined, as long as we act in accordance with our desires, beliefs, and values, we can still be considered morally responsible for our choices. According to this view, moral responsibility does not require the ability to choose differently, but rather the ability to act in line with one's own motivations. In contrast, incompatibilists argue that determinism and free will are mutually exclusive. If our actions are determined by prior causes, they claim, then we cannot be truly responsible for them in a morally significant sense. Incompatibilists often point to the intuitive sense of freedom and responsibility that seems to accompany human decision-making, suggesting that this subjective experience conflicts with deterministic explanations of behavior. Causal determinism implies a universe governed by fixed laws and predictable outcomes. From a scientific perspective, this predictability is often seen as the cornerstone of our understanding of the natural world. However, it also raises questions about the extent to which human beings can exert control over their lives and surroundings. Deterministic models have been highly successful in predicting and explaining a wide range of natural phenomena, from the motion of celestial bodies to the behavior of subatomic particles. This predictive power has enabled advances in technology, medicine, and engineering, enhancing our ability to understand and manipulate the world around us. Despite the successes of deterministic science, there are limits to our ability to control complex systems, particularly those involving human behavior and societal dynamics. Chaos theory, for example, reveals how even deterministic systems can exhibit unpredictability due to sensitivity to initial conditions. This suggests that while deterministic laws govern natural phenomena, the complexity of real-world systems can pose challenges to our ability to predict and control them fully. Causal determinism can also raise existential and ethical concerns about the nature of human existence and the possibility of meaningful action. The idea that every event is predetermined by prior causes can lead to feelings of existential angst and nihilism, as it may seem to undermine the significance of individual choices and the possibility of genuine agency. Some individuals may struggle with a sense of fatalism or resignation in the face of a deterministic worldview. Determinism can also have implications for our understanding of ethical principles and moral judgments. If human actions are ultimately determined by prior causes, it may call into question traditional notions of blame, punishment, and reward. Some argue that a deterministic view of human behavior should lead to a more compassionate and understanding approach to moral judgment, recognizing the complex web of influences that shape individual actions. Causal determinism raises profound questions about the nature of human experience, the limits of scientific knowledge, and the foundations of morality. While deterministic frameworks have been instrumental in advancing our understanding of the universe, they also challenge deeply held intuitions about free will, moral responsibility, and the nature of causality. The implications of determinism continue to be a topic of lively debate among philosophers, scientists, and ethicists, reflecting the enduring complexity of these fundamental questions. The exploration of causal determinism has taken us on a journey through the annals of human thought, from the ancient musings of pre-Socratic philosophers to the cutting-edge research of contemporary scholars. Throughout this history, the concept of causality has served as a fundamental pillar of inquiry, shaping our understanding of the universe, human behavior, and the very nature of existence. As we conclude our examination of causal determinism, we reflect on the multifaceted nature of cause and effect, the intricacies of deterministic frameworks, and the enduring questions that continue to captivate the human imagination. Our journey began by delving into the historical foundations of causal determinism, tracing its roots to ancient civilizations, where early thinkers grappled with the questions about the ultimate nature of reality and the relationship between cause and effect. From the deterministic worldview of ancient Greek philosophers to the theological debates of medieval theologians, we witnessed the evolution of deterministic thought across diverse cultural and intellectual traditions. Throughout history, philosophers have engaged in lively debates about the implications of determinism for human freedom, moral responsibility, and the nature of reality. From the early modern musings of Descartes, Spinoza, and Leibniz to the contemporary discussions of compatibilists, incompatibilists, and emergentists, we explored the rich tapestry of philosophical perspectives that have shaped our understanding of determinism and its implications for human existence. The scientific revolution of the 17th and 18th centuries ushered in a new era of scientific inquiry, where pioneers like Galileo, Newton, and Laplace laid the foundations for modern deterministic thought. From Newton's laws of motion to Laplace's vision of a clockwork universe, we witnessed the emergence of deterministic frameworks that transformed our understanding of the natural world and paved the way for centuries of scientific progress. The 20th century brought profound challenges to the deterministic worldview, as discoveries in quantum mechanics, chaos theory, and the philosophy of science raised questions about the nature of causality, predictability, and human agency. From Heisenberg's uncertainty principle to the emergence of chaos theory, new perspectives emerged that challenged classical determinism and invited reevaluation of our understanding of cause and effect. In contemporary thought, the debate over causal determinism continues to evolve, with scholars exploring diverse perspectives on the nature of causality, free will, and moral responsibility. Compatibilist, incompatibilist, and emergentist viewpoints offer unique insights into the complexities of deterministic frameworks and their implications for human understanding and ethical reflection. As we conclude our exploration of causal determinism, we recognize that the quest for understanding is an ongoing journey, marked by continual inquiry, discovery, and reflection. The challenges and complexities of determinism invite us to embrace humility in the face of uncertainty, to engage in interdisciplinary dialogue, and to remain open to new ideas and perspectives that may enrich our understanding of the universe and our place within it. In the grand tapestry of human knowledge, the concept of causal determinism occupies a central thread, weaving together the insights of philosophy, science, and human experience. As we navigate the complexities of cause and effect, let us remain ever curious, ever humble, and ever mindful of the profound mysteries that continue to inspire our quest for understanding. Thanks for tuning in. I hope you found this video informative and thought-provoking. This is the point where others tell you, if you enjoyed it, please give it a thumbs up and consider subscribing for more content just like this. But we know that that kind of thing is for losers. Don't be a loser. And as always, I welcome your feedback and ideas for future videos in the comments section below. Until next time, keep exploring, keep learning, and keep embracing your inner nude, dude.